Thank you. Everyone hear me okay? All right. Shyam Krishnamurthy, I work as a senior manager in the AWS IoT team, focusing specifically on Amazon FreeRTOS, which is our embedded IoT operating system. I think everyone here, you're probably very familiar with the IoT industry itself, if you've been in tech. And if you're familiar with AWS IoT, let me know. How many of you use it? How many are familiar with it? Hands? 1, 2, OK. So we're going to do maybe a couple of minutes just introducing AWS IoT, what it's for. We're going to talk a little bit about the software we provide for devices. And then we'll dive into Bluetooth Low Energy support that we added this week as part of Amazon FreeRTOS. So let's dive in. So we're going to talk about Amazon FreeRTOS, which is part of the AWS IoT suite of services and products. So what do we mean when we say, OK, AWS IoT is a suite of services? When we talk about IoT, whether that be home automation, whether that be industrial automation, whether that be medical devices, there's usually a common pattern. People are taking embedded devices around the house, they're collecting data from it, they're controlling it, and they're trying to make sense of that data. In order to do this, and in order to drive better value that drives these machines to be smarter, you have to collect that data. You have to connect it with other systems. And you have to be able to analyze that data. So as part of AWS IoT, we have a number of cloud services that allow you to interconnect various devices using different protocols. MQTT is a popular protocol for deep embedded small devices, very lightweight. But your phone may be using HTTP. Your operators may be having a WebSocket stream. And so AWS IoT allows all of these different systems to connect through a central IoT core gateway and messaging, provide security so you can have devices authenticate with the service using certificates, customers authenticate using Cognito or AWS credentials, and intermessage with each other. So that's the first part, right? You can now connect all these devices together. Now you want to make sense of that data. And that's where we have a number of analytics and intelligence, fleet audit and protection services like AWS IoT Defender. And we have device management services that allow you to group and categorize your fleet of devices and send them over-the-air updates and so on and so forth. So if you look at this, what this does is it says, OK, if you are a device manufacturer, again, any domain, you can operate these devices and you can use them from the cloud. What I'm going to focus on now is this empty box on the left, which is, what about the actual devices? What about the local environment, whether it be the show floor, which may have hundreds of sensors, hundreds of devices that are collecting various things like temperature, pressure, and so on and so forth, hundreds of actual controllable devices like lighting systems. And how do you then connect all of them securely to the cloud? Sometimes they may be really low power devices, like Bluetooth Low Energy devices, because they're based on a microcontroller that has to save power, run on a battery for a year or more. And that's where Amazon FreeRTOS comes in, where we are a deep embedded IoT operating system based on the very popular FreeRTOS kernel. And it can run on a microcontroller device that is 1,000x order less memory than a regular Linux or Android device. The sweet spot for many of our devices is between 128 kilobytes of RAM and 512 kilobytes of RAM. So very little space. And what we're trying to do is allow these really tiny devices to connect to the cloud, to connect securely to the cloud, to receive updates, to be able to be controllable, and to be able to send telemetry and metrics to the cloud. We also are a sister product is Greengrass, which runs on gateway class devices. Because when you have these really low-power devices, many of them may not have direct internet connectivity, and they may connect through other hubs. Some of those hubs may be mobile phones, some of them may be routers, and some of those could be custom industrial gateways that are built using Greengrass. So that's sort of the spectrum of all the things that AWS IoT offers. And within that, now you can sort of apply this pattern and say, OK, I could build a home automation system, an industrial automation system, a medical device system, and use all of these building blocks to really chain that full loop where you're collecting data, analyzing it, making sense of it, driving better actions back down to devices. So this is a demo session. So I'm going to stop here for the overview, dive quickly into a few subsections. Let's talk now, zoom into Amazon FreeRTOS. Amazon FreeRTOS, you think about these small devices, microcontroller based. Typically, the functionality of these small systems is what customers want to do when they're building devices, right? But you have to add all of this additional stuff to it in order to be able to connect it, to secure it, to update it. Things that many people take for granted in larger operating systems. But these have to be brought in, ported to the custom hardware, and be built for each device individually. And that's where Amazon FreeRTOS takes the FreeRTOS kernels, and we offer all of these different pieces as part of the Amazon FreeRTOS package. It's modular, so you get to be able to take a lot of the work that we've done as standard packages. You can just use it from your application, but you can also say, oops, that went forward a little bit faster than I expected, sorry. You can also use this with different pieces that you might be able to substitute yourself. You bring in a different library or a different piece of hardware, you can just port the layer and all use the other building blocks as is because they're all modular. Sorry about that transition there. So to the right side, I've got some of these benefits that I've listed for Amazon FreeRTOS, right? It's all open source. You can go to GitHub. You can check out the full package, the FreeRTOS kernel, all of the libraries. It's available. It helps you really focus on that piece of functionality that's core to your business. And you get to also try, what device is suitable for my particular project. Some of them have different power characteristics. Some of them have different communication protocols. And we focus on enabling a wide ecosystem of devices for this. So let's now talk about what I'm here to demo, which is Bluetooth Low Energy. So one of the things that our customers have told us is when they're trying to build these low-power devices, they really want to have Bluetooth Low Energy support. They also want to be able to program these in such a way that sometimes they switch chipsets. Sometimes they have an application layer that doesn't really want to be different because they have some Wi-Fi enabled devices, they have some Bluetooth enabled devices. But the application does the same thing. It's just about where it's installed and how it's collecting that data. And so what we've done is, earlier this week, we launched Bluetooth Low Energy support for Amazon FreeRTOS. And it gives you the baseline of standard Bluetooth features, GAP and GAT profiles. It lets you have a standardized API. So typically, when people are developing against microcontrollers, you're using custom APIs for each of the stacks you're picking, each of the drivers you're picking for the microcontrollers. We work very closely with our hardware manufacturing partners to have a standardized API with port layers that are tested and available so that the application can be written once and run on any of these, and you can choose the hardware that is appropriate for you. We have companion iOS and Android SDKs that will actually demo, that'll go through this. And we also have two things that are unique here. Custom profile for MQTT. So MQTT is the application protocol that most of these devices use to communicate to the cloud. We have a profile that actually enables you to send MQTT data over BLE to the phone, proxy it to the cloud. And we also have a custom profile that lets you provision Wi-Fi credentials for dual mode devices so that when one of the common problems for a Wi-Fi device is how do I bootstrap it? When I install it, how do I get the credentials on it? And Bluetooth Low Energy is a great way to first quickly use a phone application, for example, send the credentials to the device without sort of switching AP mode and wireless and so on. So a couple of slides I'm going to skip over in time. It just talks about the MQTT feature and the Wi-Fi provisioning. What I have here for the demo is the screenshot, but we'll go straight to the actual demo here. I have a Amazon FreeRTOS board, which has some sensors. I have another board here, and I have an iPad, which is running our iOS SDK, and an application in it. And in this iPad, it's currently a demo that is configured to run as an MQTT proxy. So if you go back to the slide, you'll see what's happening is that the device, the Amazon FreeRTOS device, in this case, sensors, actuators, things that are sensing the environment, sending data to this iPad, which is then connected to the cloud. And I'm going to switch over quickly, see if that's still going. You see those graphs right there? Those are essentially sensors are not calibrated, so don't trust the actual numbers here. But this is real-time data that's going from this device right now, connected to my laptop just for power, but going to the iPad, and then going to the cloud, and showing up through AWS IoT and graphed. A little thing here, which hopefully we can see up there, is you can see that brightening up. That's a light sensor. Take my phone away. That's that. Move my hand up. You should see the temperature rising a little bit, right? So that's essentially real-time transmission of sensor data over the Bluetooth Low Energy protocol to your interim. This iPad could have been a phone. This device could be, for example, a wearable, and you're sending all of your fitness data to the cloud, for example, things like that. So that's sort of a use case as an example that you could use this for. The thing that I'm going to show you now is, because we use MQTT, which is the standard protocol many of these devices use, including if you're directly connected to the internet, applications don't have to think about the transport. They can still call the same MQTT publish. So I have another device here, which I had earlier provisioned with Wi-Fi credentials. So if you look here, it talks about connected with BLE. I have another device which I'm going to plug in just for power. Oops, sorry. Where's the... OK. There we go. So that was provisioned over Wi-Fi. The application's exactly the same. And instead, I need to find a way to scroll this. There we go. OK. So the idea being, the applications are the same. They send it over Wi-Fi or Bluetooth Low Energy. That one is going over Wi-Fi. I just lost one of the pins there. And we also have the same support on multiple chips. So if I go back here to my slides, we have 3 chips that we launched with. So this is in beta right now. You can go try it out. It's on GitHub. Use the Amazon FreeRTOS GitHub repo. You go to a branch, BLE beta branch, and the code for the BLE feature, the MQTT profiles, the Android iOS SDKs, they're all available for use. You can use any of these 3 chips from our partners. The first one is a Espressif chip, which has both Wi-Fi and Bluetooth. The second one is a Nordic NRF52, which is a Bluetooth chip. And the third one is a ST micro chip. We earlier supported a ST micro Wi-Fi enabled device. Now we have a Bluetooth variant that our partner has provided. And we're also awaiting a new chip that's a single SoC from ST, dual core, and it'll support Bluetooth 5.0. So that's coming next year as well. And we'll keep expanding this ecosystem. So hopefully that helps you understand what we're doing here with Bluetooth. It's a quick demo, so we ran through it fast. I do have a few minutes for questions, and then I can hang out on the side for additional questions if you have anything regarding Bluetooth. Questions? Does it make sense? Yep. All right. Thank you. So I'll give you the links. All right. Did we take that off? Sorry. OK. So there's links to the getting started. So there's 2 places. There's a FreeRTOS GitHub repo, Android SDK. And then there's individual getting started guides that you can use to just go step by step, install the tools that you need to try all of these out. The demos are there as well. Thank you.